A wonderful day to everyone. In this video, we will be presenting our final laboratory experiment entitled Parallel Connected Resistance. So without further introduction, here is our presentation.
Objectives for this experiment will center mainly on parallel circuits resistance by using FET simulator to gather the values and results of the voltage, resistance, and current in the parallel circuit. Therefore, we will be determining the different values of circuit will change throughout the multiple trials of this experiment.
In this experiment, we gathered data for R1 and R2 for our trials 1, 2, and 3. Then we used the formula RT equals R1 plus R2 to get the values needed for our trials 1, 2, and 3. And the answers are the values needed for RT. Third, we used the formula I1 plus I1 is equals to IT to get the value for IT. After that, we used FET simulator to get the values for I2, IT, then IV, V2, and VT in 3 trials.
Hello, my name is Christian Gerantillo, and this is our laboratory experiment 6 on parallel connected resistances. So for this experiment, we use FET simulator once again, and we will create a parallel connected resistance. After creating the parallel connected resistance, we then collect data for 3 trials in our experiment. So we set the voltage at 85 volts throughout the whole trial, and then we set the value for the first resistor at 12 ohms, and for the second resistor we set it at 120 ohms. And we used voltmeters to determine the voltage of each resistors. So after we put the test probes at the ends of the resistors, we then turn on the switch, and after turning it on, the value for our current one is 7.08 ampere, and for the second current is at 0.71 ampere. And for our total current, we have a value of 7.79 ampere. And for voltages 1, 2, and the total voltage is at 85 volts. So for the second trial, we set the value for the first resistor at 15 ohms and the second resistor at 30 ohms. And after turning on the switch, for our first current, we get a value of 5.67 ampere and our second current at 2.83 ampere. And for our total current, we have a value of 8.50 ampere. For our voltages 1, 2, and our total voltage, the value is 85 volts. For the final trial, we set the value of our first resistor at 20 ohms and our second trial at 50 ohms. And after turning on the switch, for our first value for our current is 4.25 ampere, and for our second current is at 1.70 ampere. And for our total current, we have a value of 5.95 ampere. And for our voltages 1, 2, and our total voltage, the value is 85 volts. So after finding all the data for trials 1 to 3, for the resistances, current, and voltage, we then listed down all the data in our table. And to find the total resistance, we will use computation to find it. So the formula we are going to use is 1 over R1 and 1 over R2. So for table 1, we find the LCD of 12 and 120. And after finding the LCD, we then add the value of 10 over 120 and 1 over 120 to get a value of 11 over 120. For number 2, we find the LCD of 15 and 30. And after finding it, we then add it together to get a value of 3 over 30. And for our final total resistance, we find the LCD of 20 and 50. Then we add the value of 5 and 2 to get 7 over 100.
We have analyzed that throughout all our trials, the voltage remained constant at 85 volts. The values for resistance and current are not constant and vary throughout the trials. During our trials in the FET simulator, we have observed that when the first value for resistors is high, the value for current is low, and vice versa. Therefore, they are inversely proportional.
For the conclusion, all of the data gathered and results lead to conclude that throughout all of the trials, the voltage remained constant while the value of the resistance is not constant. Using FET simulator as the basis of this experiment, it led to a result which the value of resistance is high while current is low. Then our results being the charges between resistance and voltage are inversely proportional to each other.